Alright, so now that I've done that horrible cat problem, I'm going to try number 6 from the review sheet that Mr. Rose gave us. And this is one that strikes me as kind of tricky. And at first I thought it was a typo and it couldn't be done, but it actually can. So we have a small rocket launched vertically, attaining a maximum speed of 1.00 times 10 to the second meters per second, 100 meters per second, at burnout, and thereafter coasting straight up to a maximum altitude of 1,510 meters. Assuming the rocket accelerated uniformly while the engine burned, how long did the engine fire and how high was it at engine cutoff? Ignore air resistance. So this is a good problem. So what I want to do here is, let's see where my pin is. Let's right about there. Okay. So let's set our problem up. So let's say here's the ground and positive y direction this way. So the ground, y equals 0, and the rocket coasts up some distance to what I'm going to call yb. It doesn't coast, I'm sorry, it accelerates uniformly. So it has some acceleration. I'm going to call this yb for y burnout, and we're going to call this a sub b for acceleration during the boost phase, which is up. So it has some acceleration. Initial velocity is 0, and starts at time 0 on the ground, and then it gets up there at some t sub b time burnout and has some burnout velocity. And then after that it coasts all the way up to a maximum altitude. Let's see how high I can take it's on the paper. To a maximum altitude of y max equals 1,510 meters. At that point, its velocity is going to equal 0, and the time equals, oh, who knows. Now let's see, let's make sure we know what we need to find here. We need to find how long the engine fired and how high it was at engine cutoff. So what we're really interested in is y sub b and t sub b, because these are the times, this is the position and time when the engine finished firing, and that's what we're asked to find. So let's start, and velocity at burnout we know, right? So let's go back and take a look at that. Velocity at burnout was 1.00 times 10 to the second meters per second. 1.00 times 10 squared meters per second. Alright, so given that, what I want to do is, we know at burnout or at the top of its flight, its maximum altitude, we know its speed when it reaches that maximum. So let's see if we can find out how far up the maximum was from the burnout position. So let's see if we can find this distance here, which is going to be y max minus y sub b for y burnout. Okay, now I think this is doable. We know the velocity at the beginning, we know the velocity at the end, we know the acceleration in this part was negative g, so acceleration was going downward, and what we need to find is the distance. So we can take our equation, b squared equals, so v final squared equals v initial squared plus 2 times acceleration times the change in y, and we can plug in because we actually know all these. Final velocity is when it reaches its peak, that's at 0. Initial velocity is velocity at burnout, so I'm going to put that at vb squared, and I'm going to say, actually it should be a negative 2 times g, and then the change in altitude there is going to be y max minus y sub b. Right? Right. Okay, so what we're trying to find here is, we know y max, right? We know g, and we know velocity at burnout. There's y max we know. And what we're trying to find is this, y at burnout. So we can rearrange the equation a little bit. 2 times g times y max minus y sub b equals v sub b squared, and then we just take 2 times g times, actually let's do this. Let's do y max minus y sub b equals v at burnout squared over 2g, and then we can say y sub b equals y at max, or the maximum altitude, minus burnout velocity squared divided by 2g. Let's see, is that right? We bring the yb over there, it becomes positive, bring this back over, it becomes negative, and y, so this here is something useful. Specifically, it gives us our burnout altitude as a function of everything else. So then all we need to find is the time it takes to burn, right? So we take this period here, we know the beginning and end, we know this is yb, and we know this is y naught, which equals 0. So now what we do is we take y equals y naught plus initial velocity times time, v naught t, plus 1/2 a t squared. And this is not free fall because it is accelerating. The rocket engine is firing, so that's why we have this a here instead of a g, because it is accelerating upward. So y at burnout, which we know, equals, and y naught is 0, v naught is 0, so what it really is just 1/2 a time squared, and that's the time at burnout we're looking for, so it's t sub b. And this just tells us what our time at burnout and our y at burnout interrelate. And what we wanted to find, I believe, was acceleration, wasn't it? Let's check that. Let's see. What we wanted to find, how long did the engine fire and how high was it at engine cutoff? Assuming the engine, oh, well that's interesting actually, because we don't know. Oh, okay, so this is actually this is almost how high? Yeah, right. So that's one equation that'll help us, and another equation that'll help us is we know velocity at burnout is going to be initial velocity plus the time it takes to burn times a. So, or we'll call it a sub b for burn acceleration. Actually, I'm going to put a b over here too on this part, so that we remember that's our burn acceleration, not, you know, say we remember that's not g basically. So v naught equals 0, right? So we can say vb equals, v naught was 0, ab tb, and that sounds all cute and everything. So what we can do actually is then say that we can take that equation and rearrange that to determine that AB is VB over TB. Okay, so then we take this equation here back on the left and we plug this into it, and what we can find is that y at burnout equals, and we plug in AB there, right? So 1/2 AB is VB over TB, so VB, and then we have the TB squared here divided by a TB, so this is going to be VB TB. So its altitude of burnout is 1/2 of the burnout velocity times the time of the burn. So in that, let's see, we know YB and we know VB, right? So we just need to find TB. So let's find TB in terms of YB and VB. And all these B's are sounding pretty hilarious right now. Haha. Okay, so let's do 2 TB equals 2 YB over VB. Okay, and YB, remember up here was this, right? So we can actually take that down and plug it in, and what we're going to get is, I'm just going to rewrite it all. TB is 2 times Y max minus VB squared over 2G all over VB. And so TB, and let's just let's bring this up here. TB equals 2 Y max over VB minus, and then we have this 2 here divided and this 2 multiplied, and then our VB squared divided by VB. So actually what this ends up being is VB over G. So now we're actually in very good shape because we know all these things, right? And we can find the time to burn out. And let's check back again and find out what the hell we were supposed to figure out here. How long did the engine fire and how high was it at engine cutoff? So actually these are our two answers here. Right here is TB and here's our YB. So let's plug in numbers real fast and see if these work. Let me move our window down a tad bit so we have some space here, and plug in numbers. And as I recall, Y max was 1,510 meters. G is, of course, as always, good old 9.8 meters per second squared. Actually, I'm going to forget to leave G positive. G is positive. Or at least the way we like to do it, it is. And V at burnout is 100 meters per second. So let's plug those in and see YB is, so we had Y up here. YB is Y max 1,510 minus VB squared 100 squared over 2 times 9.8, right? And that's going to equal, let's pull up our little Windows calculator. Come on, Windows calculator. Let's see. Accessories. Man, where the hell is this? Ah, there we go. Calculator. Yay. Over here. So let's take 1,510 minus 100. There's no squared, so times 100. And then divide that by 2. Divided by, oh no, see, it's already screwing us up, so hang on, let's clear all this. Okay, so 100 times, no, hold on. Blech. 100 times 100 divided by 2 divided by 9.8 equals that. So that's the second term there. Make it negative. Plus, wow, that's almost too convenient. That's 510, and that's going to equal 999 point. So actually what this really equals is, we're going to just call it 1,000 meters was Y at burnout, and then T sub B, let's see if we get this right, is 2 times Y max 1,510 meters, and you can leave the units in or not as you choose, over V at burnout, which is 100. Okay, yes, minus V at burnout 100 over 9.8. So let's see if we can make our little calculator actually do this correctly. 2 times 1,510 divided by 100 equals 30.2. So this equals 30.2 minus, and then we take 100 divided by 9.8 minus 10.2, and that so equals 10.0 seconds. So that's our burnout time is 10.0 seconds, and our burnout altitude is 1,000 meters, and that is frankly just a little too convenient, so because it means our acceleration is going to be pretty easy to find, but we're not really interested in that right now because we're over time. So there's your answer. Bye.